to be looking at our Unit 5 review for multiplying fractions. I'm so glad that you're here to join me for this opportunity. Again, if you're live streaming, feel free to comment and I'd be glad to stop, pause, and answer any questions that you have. If you're joining me for just rewatching it as it's posted, feel free to rewind, fast forward. But just as a reminder that you're going to be able to collect letters throughout this video to spell a word. And then again, write that on a piece of paper and submit it for a very special prize. So let's go ahead and begin. We're looking at our Unit 5 multiplying fractions review. So I've got my paper in front of me. I've got some scrap paper to ensure that I'm able to show my work because we know you're required to show your work. And then a nice pencil because let's face it, in math, we make mistakes. I make them all the time. So here we go. Let's go ahead and get started. So number 1 says, an expression is shown. What is the value of the expression? Now in my mind, I have plenty of room here to show my work. But if you felt like you did not, you could just go to your scrap piece of paper. So let's just go ahead. I'm going to go over here. I'm going to go ahead and do number 1 because I want to make sure it's nice and organized. That way I can A, follow it, and B, that if you submit it to me, that I am able to follow it. So I'm going to go ahead and rewrite this as 3/7 times 8/12 equals. So this truly is the most basic form of what you can do with fractions. It really is just multiplying fractions across. We talked about how you could draw an area model. So I'm just going to demonstrate that very quickly. I would draw my little rectangular area model. I would label one side as 3/7. Doesn't matter which side because we know that with multiplication we can multiply our factors in any order. And then I would label the other side 8/12. I would divide this side into 7, so I would need to draw 6 lines. 2, 3, 4, 5. Okay, let's try it. 1, 2, 3, 4, 5, 6. So I drew 6 lines to show 7 parts, and I would shade 3 of them. That shows 3/7. And so that I've multiplied 3/7 going across, and I would do the same thing now going down with that area model. You know that we're cross multiplying. We're multiplying our length times our width, basically area model, length times your width. So I would do this one, I would divide it into 12, so I'm going to need to draw 11 lines to show 12 parts, and I would shade 8 of them. So 11 lines means I can do 1 here and then 5 on each side. Ooh, it's going to be small. 2, 3, 4, 5. All right, that's going to be really tight. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I did 11 lines to make it into 12 parts, and then I would shade 8 of them. This is really terrible because you can't see it super clearly. But what we talked about in class is that overlapping part is where you find your answer. You count how many pieces are overlapping out of how many pieces total. I'm not sure what that was about, but we're just going to hang up on that phone call. They just ruined my classical music medley. Not cool. Not cool at all. So anyways, yeah, you could draw the model. Some of us like models. Some of us are past the models at this point. And we would just multiply our numerator times our numerator, which would give us 24. That was our overlapping part here. When we shaded 3 across and we shaded 8 down, we ended up with 24 overlapping parts. I would do the same thing. I would multiply my denominator times my denominator, which means we had drawn 7 across and 12 down. We had turned it into a total of 2 times 7 is 14. Grouping that 1. 7 times 1 plus 1 more is 8. So we divide it into a total of 84 parts. So if you get here, this is a totally acceptable answer. However, when we have multiple choice or multi-select, it could be this answer, it could be another one, it could be a combination of answers. So I need to figure out, well, what do I know about these two numbers? If nothing else, hopefully you recognize that they're even, so they could both be divided by 2. I don't know if there's a larger factor, so let me think. I know my factor pairs are 2 and 12. Oh, well, I know this could be divided by 12 because I multiplied by 12 to get there. So actually, both of these could be divided by 12. If you didn't recognize that, you could divide by 2, and then you'd end up dividing by 2 several times to get here. So 24 divided by 2, 24 divided by 12 is 2, and 84 divided by 12 is 7. So you get a total of 2/7 as your answer. So these are both possible answers. They're both equivalent. Select all, could be both of them. For the purposes of today, I like us to get to 2/7 because I'm much more familiar with what does 2/7 look like as opposed to 24/84. Okay, so let's look at number 2. I'm going to do the same thing with number 2. I'm going to go to my nice little piece of paper here. I'm going to rewrite it. If you're collecting letters, right now you can write the letter F. That's going to be your first letter for this video. And again, collecting those letters and submitting them for a prize. So I'm going to multiply 5/8, and I'm going to multiply it times 9/14. So same thing that we've already been doing, numerator times your numerator would give you 45, and your denominator times your denominator. Let's see, 8 times 4. 8 times 4 is 32. So I'm going to put down that 2 and regroup that 3, and then I would do 8 times 1, and then adding on that 3 that I regrouped. So 8 times 1 is 8, plus the 3 more gives you 11. So you come out with something that looks like this. And again, can it be simplified into a lesser equivalent fraction? I'm not really sure. I know my factor pairs for 45 are definitely 5. This definitely can't be divided by 5. I know 9. Let's see, if I divided 112 by 9, would that work? 112 divided by 9 could go in one time because 9 times 1 would mean I'd take 9 away. And I'd have 22. Oh, nope, 9 won't work because I know that 9 can't go to 22, so definitely not 9. 45, could it be divided by 3? 45 divided by 3 could go in one time, which would be 15 times evenly. Could 112 be divided by 3? Could go in 3 times. 4 is too much. 3 times 3 is 9, which would leave me with 22 left over. Oh, so that won't work either. So in my mind, I don't know that it can be simplified. I don't think that it can be simplified. So I'm just going to leave it as is at 45 and 112. The likelihood is that if you're getting somewhere here, they're probably just going to accept that you have an answer. But again, you always are wanting to check, can I make an equivalent fraction? And we know we could go up on it, but could I go down on it? And that, I don't know. I'm going to assume no. Let's look at number 3. So number 3 is a word problem, which means I'm going to use my strategies. I'm going to use cubes to help me solve this. So on number 3, it says Michael is dividing his garden into plots so that each plant has its own plot to grow in. It's very nice of you, Michael. Some of his plots have already been planted. Each plot has a side length of 1/3 foot. What is the area in square feet of the unfinished garden plot? And so he's got this beautiful garden plot here. And if I'm unwrapping it, I'm going to circle my numbers and what they represent. So I've got 1/3 representing, oops, that says slide. It should be side. 1/3 representing the side length. I don't see any other numbers, but I do see a question, which is what is the area in square feet of the unfinished portion? See this word dividing, meaning he's making off sections. So I'm going to go through and now I'm going to try to solve it. So I know that this is the finished part, and here's my unfinished part. So maybe I'll start out by figuring out how many plots are unfinished. So if you wanted to, you could actually draw little light lines across, and you could count and see how many boxes there are that have, or how many plots there are rather, that have not been finished. Or you can just count. There's 1, 2, 3, 4, 5 going down missing, and 1, 2, 3, 4, 5, and then you'd multiply your length times your width. There's 5 down and 5 across. The area, the amount of plots that is, there are 25 plots that are unfinished. However, I have not yet answered the question because I know that each side length of the plots is only 1/3. So if I wanted to find the area of one plot, I could multiply 1/3 as my length times 1/3 as my width. And that would tell me the area of just one of these. So 1/3 times 1/3 equals, and then you just multiply your numerator times your numerator and your denominator times your denominator. So I would end up with 1/9. So 1/9 is the area of just one plot, but I don't have one plot unfinished. I have 25 plots unfinished. So I could add 1/9 plus 1/9 plus 1/9 plus 1/9 and go on and do that 25 times. Or I could multiply by 25 whole. So in this instance, we know that when we're multiplying a whole number by a fraction, we're really just multiplying that whole number times our numerator, and our denominator stay the same because, again, 25 whole is equivalent as a fraction to 25 over 1. So 25 times 1 is going to give us 25, and then 9 times 1 is going to give us 9. Again, whole number times your numerator, denominator ends up staying the same. So I get 25 ninths. Again, this is totally an acceptable fraction, but on multiple choice or multi-select, you might see it different ways. So I could also regroup 25 ninths and turn it into a mixed number. So 25 could go into 9 how many times? Let me think. 9, 18, 9 times 3, 27. Oh, 27 is too high. It can't go in 3 times, so it went in 2 times. So 2 times 9 means I took away 18 ninths. So 25 take away 18. If I didn't know that, I could rewrite it going up and down, or I could start at 18 and count down to 25. So I could go 18, 19, 20, 21, 22, 23, 24, 25. And I realized that 25 take away 18 is 7. And my denominator would then be ninths. So 2 and 7 ninths. And what is my unit of measurement? My unit of measurement is feet. So you could see it both ways. One of the possible answers could be 25 ninths feet, or another answer could be 2 and 7 ninths feet. So either one, or feet squared, square feet, right? Squared because it's area. Either one of these are totally acceptable answers. So I'm going to do the same thing with number 4. Number 4 says that Tanya is filling her walls with square-shaped posters of her favorite bands. Each poster has a side length of 1/4 yards. She has filled part of her wall, but still has more space to fill with posters. What is the area in square yards that Tanya still has available to fill with band posters? So first of all, I want to think, well, what is the area of one poster? And in my word problem, I've got the side length of 1/4. I've got my question. I know I'm looking at area, which is my length times my width. So first I'm going to find the area of one poster by multiplying my length times my width, 1/4 times 1/4. So 1/4 times 1/4, that's going to give me the area of one of the posters. So 1/4 times 1/4 is going to give me what? Right, it's going to give me 1/16. But that's only one of the spaces. I need to figure out how many poster spaces she still has available. So she's got 1, 2, 3, 4, 5 boxes down times 1, 2, 3, 4, 5, 6 going across. So she's got 5 posters going down and 6 posters going across. So she's got 30 poster spaces still available. So I'm going to take those 30 poster spaces and multiply by the area of 1. So when I do this, I can do my whole number times my numerator, and again, my denominator is going to stay the same. Because if I wanted to express this as a fraction, it would be 30 over 1. 30 divided by 1 is still 30 whole. So I would end up getting this beautiful answer of 30/16. So that's one possible way to express that. 30/16 unit of measurement is yards squared, or square yards. Or I could also take that same answer and regroup it into a mixed number, which again, this is an important skill to be able to be completely flexible with our numbers. I can go up, I can go down, I can regroup, I can do all those things. So how many times can 16 go into 30? And hopefully you recognize that because you know your clock time for 15s, and this is a little bit more than 15. So if it was 15, it could go in 2 times, because 2 times 15 would be 30. It's a little bit more, so it can actually only go into 1 time. And 1 whole would mean I'm subtracting 16/16. So 30 take away 16 would leave us with what? Some of us friends would want to go over here to the side and subtract. And so when you take that away, you actually are going to end up with 14/16 because your denominator is the same. But what do I know about 14/16? Right, it can be made into an equivalent fraction. They're both even, so I know if nothing else, they could both be divided by 2. So 14 divided by 2 is 7, and 16 divided by 2 is 8. So in this instance, I actually was able to come up with 3 ways to represent this unfinished area. Again, if I'm flexible with my numbers for select all, you would maybe need all three of those. So we always have to be flexible with the way that we express our equivalent numbers. Okay, if you're collecting letters, your next letter that you should collect is the letter A. So you now have 2 letters. If you missed a letter, you should probably go back and watch a little bit more carefully. Number 5 says, of the students enrolled in Too Good for Drugs, 1/5 take the class on Mondays. Of those students, 4/7 are girls. What fraction of the students enrolled in Too Good for Drugs on Mondays are girls? Woo! I love it. So why I love it is because it has multiple ways to do the same thing. Or not the same thing, multiple steps. I love multi-step word problems because it really makes us think. The math is not hard, but making sure that we're answering what the question asking is our next step. So of the students enrolled, 1/5 are taking the class on Mondays. Of those students, 4/7 are girls. What fraction of students enrolled in Too Good for Drugs are girls? So operation word. Let's see, I've got 1/5 take on Mondays. Of those, of is telling me to perform an operation. What operation is of telling me to perform? Right, of is telling me to multiply. I'm going to take the 1/5 students that are taking it on Monday, and of those 1/5 students, 4/7 of those are girls. So I'm just going to multiply these two fractions straight across, and from here we've got a pretty easy answer. Numerator times your numerator, denominator times your denominator. I am certainly not doing that for you. You can do that. So we're just going to move on and go right on to the next one. Next one, number 6 says, of the students in 5th grade, 1/6 are safety patrol. Of those 5th graders, 2/9 are captains. What fraction of 5th grade students are safety patrol captains? Again, I love this problem. It's really got you thinking. So let's see. Of the students in 5th grade, 1/6 are safety patrol. Of those, 2/9 are captains. And again, I'm always using my cubes to unwrap my word problem to make sure that I understand what the question is asking me. And this one says, what fraction of 5th grade students are safety patrol captains? So operation word. What is my operation word? Do you see an operation word? Right, my operation word is of. Of is telling me to perform what operation? Right, of is telling me that I need to find 1/6, and then of those, I'm going to multiply. 2/9 of those are going to be 2/9 of those are going to be safety patrol captains. So just multiply that across. Again, when you get to your final answer, I'm not going to multiply this with you, but when you get to your final answer, think, can I turn it into an equivalent fraction? Can they both be divided by the same number or multiplied? We don't usually do multiplying, but we're flexible with our numbers, so we can definitely do both. Let's look at number 7. Number 7 says, Eric is baking brownies. Each batch requires 2 3/4 cups of flour. If Eric only wants to make half of a batch of brownies, how much flour does he need for his brownies? Ooh, Eric, I like brownies. Yummy. Yummy, yummy, yummy. I love it. Okay, so each batch requires 3/4 cup of flour, and he only wants half a batch. Weak. Okay, I'm not going to judge. So how much flour does Eric need for his brownies? So an operation word. He only wants to make half of a batch. Oh, of again is telling me that I'm going to multiply. I'm going to find 2 3/4, and then I only want half of that. Now, I want you to be careful and make sure that you don't just try to multiply your fraction times your fraction and then carry over numbers. Then you've missed the whole point. When you're doing this, you're really multiplying the whole number times the half and the fraction times the half. So what we've been doing in class is we take it and we just regroup it into a fraction greater than 1. We would multiply our whole number times our numerator, or times our denominator, and add it into our numerator. So 2 times 4 is 8. So I'm adding that 8 with my 3 because 8/4 is my 2 wholes. So 8 plus 3 is going to give me 11/4. And this one's already good. There's no whole numbers with it. So I would just multiply that straight across. and I would come up with an answer, which would be 11/8. I will say that this will work, but I want you to take that 11/8 and regroup it into another fraction. So once again, what I would love for you to do is take it, regroup it, but I'm going to allow you for your next letter. If you're collecting your letters, your third letter is an L. So go ahead and write that down. That's your third letter. Remember, there's going to be 2 words, 1 word for the front and 1 word for the back. Feel free to fast forward, rewind, do what you need to do if you're tuning in later on. So number 8 says, Miss Foreman jogs 3/5 miles each day. Miss McCluskey jogs 4.5 times as much as Miss Foreman. You're an overachiever, McCluskey. You go, girl. I'm going to get there. Not anytime soon. Okay. How many miles does Miss McCluskey jog each day? So again, Miss Foreman, she jogs 3/5. She's a little winded, not going to lie. And then McCluskey jogs 4.5 times as much. How much does she? Well, she did it just 4.5 times as much as me. So she doesn't jog 4.5 miles. She jogs how much I jog? 4.5 times that much. So times as much is telling me to multiply. I'm going to take 4 and 1/2. Oops. I'm going to take 4 and 1/2. That she does 4.5 times as much as I do. Now, I could have wrote these the other way around, but again, the order of our factors does not matter with multiplication. So again, I'm going to do my whole number times my denominator, and adding it into my numerator, I now have 9/2 times 3/5. I'm not going to do this for you. You can totally do this. You can totally multiply your numerator times your numerator, denominator times your denominator. You are going to end up with a fraction greater than 1, so I want you to take that fraction greater than 1 and regroup it into a mixed number. Again, we don't know how things are going to come out on our test. We could have multiple choice, we could have multi-select, and it could be equation editor where we actually have to type in a number. So we need to be fluid where we can go always. So your last letter for this is an L. This is the front side. I'm going to do a part 2 for the back side. It's completely separate, but you now have collected a 4-letter word. A nice 4-letter word. You're going to write that on a piece of paper with your name and turn that in for a possible prize. And then again, stay tuned for the second video, part 2, which will give you your information for the backside. Again, continuing to study, continuing to apply that extra effort, because while I give you all the tools you need, it is now your responsibility to take charge of your education. I know that you can do well as long as you continue to apply yourself. Have a wonderful fall break. If you celebrate Thanksgiving, eat up. I do. And I can't wait for my turkey. Gobble, gobble, guys.